Day 12 of our 75-day LeetCode coding challenge. Today we are going to solve our next problem statement, container with most waters. So let's start. You are given an integer array, height of length n. There are n vertical line drawn such that the two endpoints of the ith line are I, 0 and I, height. Find two lines that together with the x-axis forms a container such that the container contains the most water. Return the maximum amount of water container can store. Notice that you may not slant the container. These are the test cases. Basically, you can think of this vertical line as an pillar. And suppose you have given multiple pillars and those pillars have some height attached to it. So one pillar can have height 1, then another can have 4, then 8 and so on. You need to find the two pillar that can store maximum amount of water between them. So let me repeat it. So you need to find two pillar that can store maximum amount of water. So think of it as a scenario where you have multiple pillars and you are just attaching it on the ground, and then you are started pouring water, amount of water that you can store between the two pillars. So for this first test case, the first pillar have the height 1, then the second pillar have the height 8. So basically this array is nothing, it is the height of the pillar that is given. So we can draw an xy axis where on y-axis we can check the height of the pillar, and on the x-axis we can check the distance of the pillar. So for this first pillar the height is 1 and the distance is also 1. For this second pillar the height is 8 and the distance is 2, right? And similarly for third pillar the height is 6 but the distance is 3 from 0, correct? So x-axis is telling us the distance of the pillar and the y-axis is telling us the height of the pillar. So now we need to find the maximum amount of water that can be stored between the pillar. So what is the formula to compute the how much water is stored? So store water, to find the formula is, let's write our formula here. Store water equal to length, so you can say height into width, right? So how this output 49 is generated? Basically the height of second pillar is 8 and the last pillar is 7. So one important thing also to know, the second point that we need to remember, height of water will be equal to minimum height of pillar 1 comma pillar 2, correct? And you can think in practical sense also. Suppose you have two pillar and one have the less height and one have the more height, and you start pouring water. Obviously the water can only store till the minimum height of the pillar, correct? This is the common sense also. So that's why we are saying we need to consider the height of the minimum pillar between the two pillars. So suppose in between the first and the second pillar, the first pillar have the less height, and if we start pouring water, you can only fill the water up to the height of 1, correct? So for this first and second pillar, if I need to calculate how much water we can store, we can say height into width. So what is the height of water that we can store? It is 1, correct? And what is the width? Width you can calculate simply x2 minus x1. So this will be width, x2 minus x1. So for first and second pillar it will be 2 minus 1, 1. So 1 into 1, 1. So for first and second pillar we can store 1 water only, 1 amount of water we can say. But for second and 9, let's calculate the store water for P1 and P9 pillar. So what is the height? We need to take the minimum height between P1 and P2. So for ninth pillar it is 7, for second pillar it is 8. The minimum height between 7 and 9 is, if I need to take between 7 and 9, it is 7, right? So I'm writing it. So our height is 7, and what is the width? You can say x2 minus x1. So the x2 for the ninth pillar is, you can count it 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus, for second pillar 2. 9 minus 2 equal to 7. So this is our height and this is our width. So the amount of water calculated is 49. Correct. Similarly, you can do for all the pillars, and you will find that the maximum value is 49. So we need to compute only the maximum value. And you can try it on your own, doing this computation of height into width for all the pillar. But the maximum will be 49 only. One point also we need to write that maximum water we can only store if our height is maximum. Height should be maximum and our width should also be maximum. Correct. So for this case, our height is also maximum and our width is also maximum, right? Because if the gap is large and height is also more, then you can store a large amount of water. Correct. Correct. So to solve this problem statement, we can use the two-pointer approach. Basically, we can find so the first pointer, let's write our pseudocode of two-pointer approach. We can have our first pointer pointing to the left location, or you can say to the first pillar, and the last pointer pointing to the last pillar. So we have the first index pointing to the first pillar and last pointing to the last pillars. Then we can say compute water store between first and last pillar. So we need to compute the water between the first and last pillar, and we will do it by using this formula, right? Height into width, and compute between first and last pillar. Then we can say, if you have two pointers, first pointer pointing to the first and the last pointer pointing to the last pillar, if first pillar is small, it makes sense to move pointer from left. And if the last pillar is smaller than the first pillar, it makes sense to move a pointer from the last. And why is that so? Because we have said the maximum water we can only store if the height is also maximum and the width is also maximum. Correct. So if we have the pillar that have a more height, it do not make sense to move pointer from there. We will move pointer from there of that pillar that have the less height, so that we can have the maximum height pillar, and it will improve our chances to get the pillar that have the maximum water stored. So we can say if height of pillar 1 is greater than pillar 2, our pillar 1 is pillar 1 from the left side is bigger than the pillar 2, we can say move the last pointer, else move the first pointer. And we are computing the water between the first and last pillar every time. So just we need to find max water computed. So out of all the pillar that we are computing the water storage, we can find the maximum water computed of all the possible values. It should give our solution. So let's write in the code part, and you will understand it more when we do the coding part. So let's start. So first we are saying that we have the left pointer pointing to the first pillar. We have the right pointer pointing to the last pillar. Then we are saying our left pointer should always be less than right pointer, because we are decreasing like this. As soon as they become equal, we need to come out of the loop, right? So left less than right, execute this while loop. Next, now we need to find the width and the height between those two pillars. What should be the width? Let's find first height. What is the height between the two pillars? Suppose we encounter this first and this last pillar, right? So first pillar is small and the last pillar is have the more height. So we have said कि if the one pillar is small and another pillar is big, the amount of water you can store only to the minimum height of the pillar. So between the first and the 9, if you start pouring water on it, maximum height you can go it is to the 1. So we need to consider only the minimum height between the pillar 1 and the pillar 2. So let's say height of my left pillar, height of my right pillar. Whatever is minimum, take that height. Now, what about the width? It is simply x2 minus x1. So my right index minus left index will give me the width simply. So right minus left. Right? So now I got my height and width. Let's find what is the current water store between these pillars. So current water store is height into width. So we can say height into width. Correct. We also need to define the max value, max water storage value. So we are initializing it by 0, and we are saying max water store. If current water store is having more value than our max water storage, then assign that value. So whatever is maximum between the current water storage and our max water storage. Okay, this is done. Now we need to move our pointer from left or right. So if our left side pillar have the less height than our right side pillar, then increment from the left side, else decrement from the right side. So two pointer, one is on the left side, one on the right side. If left side pillar have the less height than the right side pillar, we move from the left side, because we need to make our max water storage maximum, and it will be only possible if our height will be maximum. The other pillar height should be maximum. So we are done with this, and now just return our our max storage variable. This is done, and now let's run our test cases. So our test cases is working. Now let's submit the solution. Yeah. So thanks for joining the session. Let's meet tomorrow.